morning. So you're welcome back to this program. And today we are starting our program in full. That's our online program. We are starting today in full. Alright, so according to our program, the first on the agenda is series and sequence. And that is the topic that we are working on today, series and sequence. What do we call sequence? Sequence is a pattern. You can simply call a sequence a pattern. And when you are talking about a pattern, you are talking about a code that needed a pattern, like a code that needed a logic to be unlocked. When you are not talking about sequence now, sequence simply means a pattern. And when you are talking about series, series means sum or addition of sequence. As simple as that. That is just the whole of what we want to discuss in this topic. That's all what we want to solve and calculate in this topic. It's all about sequence and addition of the sequence. Alright, so we are starting the programming for today. We are working on series and sequence. Follow me as we start. Alright, sequence at first. That's what we are starting with. Sequence. Can somebody repeat after me? Say sequence. I can't hear you. Say sequence. Alright, so what is a sequence? As I said earlier, a sequence is a set. A sequence is a set of numbers. A sequence is a set of numbers that has a definite order. It's the same thing as a pattern, definite order, and possess a simple rule. And possess a simple rule. A simple rule that serves as a root in finding. They serve as a root in finding their terms. So that is the definition of sequence. It is a set of numbers that has a definite order and possess a simple rule that serves as a root in finding their terms. So let's see examples of this. Let's see examples on sequence. Examples. Are we following? Examples of sequence. Number one. We are having 1, 2, 3, 4, 5, blah blah blah. If you look at this, you don't need to think much about this. You should know that this is a pattern of n plus 1. N plus 1. So that's the pattern. Let's look at the rule of this. Let me write the question first. Let's see another one. 1, 2, 6, 24, 1, 20, blah blah blah. Number 3. Let's say we are having 4, 8, 12, 16, 20, and so on and so forth. According to the question, let's see. Find the roots and the next 3 terms. And the next 3 terms of the above listed questions. Let's see solutions to that. Let's see solutions to this question. Let's tackle it together. I will follow you. Number 1. We are having 1, 2, 3, 4, 5. We are finding the next 3 terms. 1, 2, 3. If you look at this very well. This is increasing by 1 mark. This implies that our rule will be equals to n plus 1, where n is equal to 0, 1, 2, 3, and that is how we continue. Now let's see if this is true. Is 0 plus 1 is 1. Are we saying it? Now, when our n is 1, 1 plus 1 is 2. When our n is 2, 2 plus 1 is 3. You can see. When our n is 4, 4 plus 1 is 5. You can see. When our n is 3, 3 plus 1 will give us 4. Which implies that this will give us 6, 7, and 8. And that is the solution to that question. Let's look at number 2. We have 1, 2, 6, 6, 24, 1, 20, and so on and so forth. We are looking for the next 3 terms. 1, 2, 3. Let's check this out. If you say 1 plus 1, it will give you 2. If you say 2 plus 1, it doesn't give you 6. You can see. But let's do something here. Look at this. 1 times 1 will give us 1. Are you following? Now, 2 times 1 will give us 2. In this place now, this implies that if you look at how the thing is going, 2 times 3, it gives us 6. Let me do it like this. 1 times 2. If you look at it, you will see that it's increasing. 3, we get 6. 6 times 4 gives us 24. Look at it. We are saying that it is the final result that we are using to get the new number. The same thing, 24 times 5 will give us 120. So this is the logic. But how do we now deduce the rule? This implies that our rule is going to give us n factorial. What is the meaning of n factorial? N factorial means that any number that n is standing for will be multiplied in descending order. That is the meaning of factorial. Multiply it in descending order. Are we getting it? That is where our rule is coming from. For n is equals to 1, 2, 3, 4, and so on. That is how we get our formula. Now let's check it out. If our n is 1, 1 times 1 will give us 1. The answer is straightforward. You can see. If our n is 2, 2 times 1 will give us 2. If our n is 3, 3 times 2 times 1. So that is where it's coming from. 1 factorial is equals to 1 times 1, which will give us 1. I want to prove this one now. 2 factorial is going to give us 2 times 1. That will give us 2. 3 factorial is going to give us 3 times 2 times 1. That is 6. Are you seeing it? You can see that it's following. 4 factorial will give us 4 times 3 times 2 times 1. 12, 24, it gives us 24. 5 factorial is going to give us what? 5 times 4 times 3 times 2 times 1, and that will give us 120. Are you seeing it? I will leave the remaining one for you to solve. What will be our answer? This is going to give us 720. 720 times 7 is going to give us 0. 14, carry 1. 49, 50. We have 5 is 0, 4 is 0. And the last one, 5040 multiplied by 8. We are going to get 0, 32, carry 3, 3, this is going to give us 40, and that is 40,320. So by the time you treat this will be your final answer, and you are done. Now for the last one, before we call it a day for today, what are we going to have? We are having 4, 8, 12, 16, and 20. We have to find the next 3 times. What are we going to have? What will be our rule? Look at it. Look at this very well. You will see that this is a multiplication of table 4, which implies that our rule is simply 4n. 4 n is equals to 1, 2, 3, 4, blah blah blah. This implies that 4 times 1 will give us 4. 4 times 2 will give us 8. 4 times 3 will give us 12. You can see 4 times 4 will give us 16. 4 times 5 will give us 20. And that's how you continue. Meaning that our 4 times 6 is going to give us 24. So this is 24. 4 times 7 is going to give us 28. So this is 28. While 4 times 8 is going to give us 32. This means this is 32. Alright? Here we come to the end of today's class. We are going to meet again next time. Thank you. Good morning. You are welcome back to our program once again. Last time we talked about sequence. Today we are talking about series. Sequence, you already know what we meant by sequence. Today we are working on series. What do we call series? Without wasting much of our time. Series, like I said the other time, simply means addition of sequence. Let's have the definition of series. Series can simply be defined. Series can simply be defined as the sum. Actually, this is my own definition. It is not textbook code. As the sum of a sequence. As the sum of a sequence. Now, before we proceed or move further, we have two types of series. We have the infinite series and the finite series. It's part of what I want to write now. There are two types of series. There are two types of series. There are two types of series, which are one, finite series, and two, infinite series. So what do we call finite series? Let us see. Finite. When we are talking about finite series, we can simply term finite series as a series, that is a sequence that has an ending. Are you getting it? Very simple and short. When you have a series, or let me say when you have a sequence that has an end, it is finite. Simple as ABC. When you are having a sequence that is not ending, that has no end, we call it infinite series. As simple as that. So let's write finite series. Finite series is a type of sequence. That has an end. As simple as that. Let's look at infinite series. Infinite series. This is the type of series. This is the type of sequence. This is a type of sequence that has no end. It has no end. You don't need to waste much time on that. It has no end. Let's see examples on that. Examples. Okay. Identify whether the following sequence is finite or infinite. Is finite or infinite? Number one, we are having 1 plus 2 plus 3 plus 4 plus ... plus 99 plus 100. Number 2, 4 plus 2 plus 1 plus ... Number 3, 4 plus 8 plus 12 plus ... plus 96 plus 100. Number 5, 2 plus 4 plus 6 plus 8 plus ... plus 100 plus 102 plus ... So let's quickly see this number 4, sorry. Now, let us work on this. Number 1, we are having 1 plus 2 plus 3 plus 4 plus ... plus 99 plus 100. Is this a finite or infinite series? As you can see this, look at it very well. You will see that after your ... it still continues, and we have a full stop. If you are saying that you are having a number that still continues after your ... it is infinite. But if you are saying a number that ends with ... 3 dots, you will know that that is an infinite series. As simple as that. What will I call this now? This is a finite sequence. Let me call it sequence because it's addition. Finite series. Number 2, we are having 4 plus 2 plus 1 plus dot dot dot. The answer is simply this is infinite series. This is infinite series. Number 3, we are having 4 plus 8 plus 12 plus dot 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 plus 96 plus 100. What are we going to get? This is infinite series. So I've done 3 out of 4. So I will leave the remaining question for you to answer. See you next time. Thank you. Good day, everyone. Good day to every of our followers that have been watching this YouTube channel. We are back to our program again. Our program remains the same, Arithmetic Program. Somebody can ask me the meaning of Arithmetic. Arithmetic Program simply means God is able mathematics online teaching and competition. That is just the full meaning of our Arithmetic and nothing else than that. So we are back again to our topic. We are still on series and sequence, as we all know. On our previous lesson that we work on how we can identify sequence and series. And I made mention that sequence is a pattern, while series is the summation of your pattern. But today we are working under some subtopic under this topic itself. And today, by the grace of God, we will be working on AP and GP. What is the meaning of AP? AP simply means arithmetic progression, while GP means geometric progression. These two key words are different topic entirely. And by the grace of God, we will be treating both the sequence and series under these subtopics. Don't forget, you are still on series and sequence, and that is why we'll be treating the sequence and series under this subtopic. Alright, so like I said, today we are working on arithmetic progression, and geometric progression. These are the two things that we are working on today. Now, before we proceed further, I want to explain to you what do you understand by AP, what do you understand by GP. These two things simply are a progression. That is something going forward, something progressing either positively or negatively. We can also apply this in our area of lives. How? Is either your life progress positively or your life progress negatively. The one that progresses negatively is known as decreasing. The progress is decreasing. The one that is called arithmetic progression positively is the one that is increasing. When we are talking about arithmetic progression and geometric progression, they are telling you that something is happening either positively or negatively. Alright? So whatever that is happening positively is what we call or we term as increase in the progress. Whatever that is negative is what we term as decrease in the progress. So with this understanding, I can simply divide my arithmetic progression to be a sequence that is increasing or decreasing with common difference. Why do I call it common difference? Your arithmetic progression deals with addition or subtraction. Take note of that. AP deals with addition or subtraction, while GP deals with multiplication or division. Meaning that for your AP, is either your sequence decrease or increase with a common difference. While for your GP, which is your geometric progression, it increases or decreases with a common ratio. So let's write something down. For those that are following us on our channel, this implies that, let's give the definition of arithmetic progression. Arithmetic progression can be divided as the increase or decrease of a sequence. Increase of a sequence with a common difference. So that is for our arithmetic progression. Let us check out for our geometric progression. Geometric progression as the increase or decrease of a sequence in with a common ratio. This is what we call a geometric progression and an arithmetic progression. Our arithmetic progression can be divided as the increase or decrease of a sequence with a common difference, while geometric progression can be divided as the increase or decrease of a sequence with a common ratio. So, on our next video, watch out for how we can identify arithmetic progression and geometric progression. Thank you. Good day to all our followers out there. You are welcome back to our YouTube channel. On our previous lesson, we talked about the definition of AP and GP. Today, by the grace of God, we are working on AP and GP identification. We want to work on the identification of arithmetic progression and geometric progression. You see that we are taking our lesson in a gradual step that will be understandable for every people that are going to be watching our channel and are going to be following us on our channel. Today, we are working on how can we identify. Don't mind my gestures. It's part and parcel of me already. So don't mind my gesture. Now, when we are talking about AP and GP, how do we identify our AP and how do we identify our GP? There is a way that we can understand them. Let me give you this simple logic, this simple pattern. AP deals with addition or subtraction. Once you are seeing a sequence increasing with a common differences of addition or subtraction, then it belongs to AP. When you are seeing a sequence increasing with a differences of multiplication or division, you are talking about geometric progression. Meaning that a geometric progression deals with increase or decrease of a sequence in multiplication or divisible way. While for your AP, it deals with increasing or decreasing of a sequence in an addition or subtraction way. Do you get it now? The next thing on the agenda is to do some examples for us on the board. Then you have your own work to do that you're going to practice immediately after watching this YouTube channel. Alright, are we ready? We are working on identification of AP and GP under series and sequence. We move to the example. Identify whether the following terms are AP or GP. Number one. Let's take some examples from our notes. We are having 2, 5, 8, 11, and so on and so forth. Number 2, we are having 2, 6, 18, 54, blah blah blah. Number 3, we are having 20, 15, 10, 5, blah blah blah. Number 4, we are having 20, 10, 5, blah blah. Yes, this is our question that we want to work on. Can we do this together before your own work to do? Let us look at this example. We have to identify whether the following terms are AP or GP. How do we know that? Don't forget that your AP increases or decreases with a common difference D. Why your GP increases or decreases with a common ratio R. In this idea, let's look at the solution together. Solution. Number 1, we are adding 2, 5, 8, 11, and so forth. How do I want to know if this is belonging to AP or is belonging to GP? Let's check it out. You see, each number that you can see there are the ones that we call our terms. And how do we detect if it is for GP or it is for AP? Through our workings. My first term is equals to 2, which is also known as A. Let us go into that yet. My first term is 2. My second term is what? My second term is equals to 5. How do I check if it is my AP or GP? Use your first term. Subtract your first term from your second term. You will know. Subtract your second term from your third term. That is how you will know what is happening. If I look at this, my D is equals to T2 minus T1. That is 5 minus 2. It increases by 3. I check again. D is equals to T3 minus T2. Now, what is my T3? That's 8 minus 5. It gives me what? 3. If you look at this, this is telling me that it is when I minus that I was getting my answer. And it is a common difference. You can see 3, that's a common difference. This implies that what? This implies that this sequence is an arithmetic progression. As simple as that. Minus is there already. Let's check out for another one. Number 2. We are adding 2, 6, 18, 54. Blah, blah, blah. How do I get this? Look at this. For my first term, 2 multiplied by 3 give me 6. Are you following? 6 multiplied by 3 give me 18. Are you saying something? Check it out. It's multiplication sign that I'm using. 18 multiplied by 3 give me 54. Now the common ratio here is our what? The common ratio is 3. While we are making use of the sign is multiplication. This implies that the sequence is a geometric progression. Number 3. Have you followed? Let's check out our number 3. We are having 20, 15, 10, 5, blah blah blah. Let's check this out. If you look at this, you see that our 20 is decreasing decreases from 20 to 15, from 15 to 10, from 10 to 5. We can see the progression that is decreasing with what? Equality number of 5, 5. Let's check it out. D is giving us T2 minus T1, which is what? 15 minus 20, giving us what? This is giving us minus 5. Check it out again. T3 minus T2 is also 10 minus 15, giving us minus 5. This implies that our sequence is an arithmetic progression. Let's check out for the last one on the list. We are having 20, 10, 5, blah blah blah. Let's check out. Our ratio is T2 over T1. This is giving us 10 all over 20. From here we get half. Let's check it out again. T3 over T2 is giving me 5 over 10. This is giving me what? 1 all over 2. This implies that this is a division. 20 divided by 2. Let me make use of this. Let me make use of this method. 20 divided by 10 give you 2. You can see it. 10 divided by 5 give you 2. This is telling you that it is when you are dividing that you are getting your common difference. your common ratio. Therefore, this implies that the sequence given is a geometric progression. This is your own work to do. Before I leave this place, try this out. Identify whether the following sequence is an AP or GP. Number 1, 4, 8, 12, 16. Number 2, 5, 3, 1, minus 1. Number 3, 2, 6, 17. I'm giving you that one before. Let me give you another one. 3, 9, 27, 81, blah blah blah. Number 4, 120, 40 over 3, blah blah. We have come through to the end of today's class. Meet us on another day for another lesson. I believe that you have gained something today. Alright? Meet us next time for another next level under series and sequence. Thank you. Good day, our followers. I believe that you have been watching all these videos. Are you even watching it at all? I don't see some people watching this. You just like, after liking, that's all. Why now? You have to subscribe onto these videos. And it will be, there are videos that are going to benefit you a lot. I don't know why you are not actually subscribing to our YouTube channel. Please, if you watch any of our links, or if you watch any of our videos, just click on the links and go straight to the YouTube channel. You are going to see the full video there. All those clips that you are watching, they are just the remnant of what we can actually provide for you under this service. Welcome back to our program, and here we are again. We are in Geometry program once again. Don't forget that our last topic, or let me say our last subtopic, ended at how to identify AP and GP. But today, we are moving fully into the program. We are moving fully into the topic. We are now entering the inside of series and sequence. You get that English now? Alright, today we will be working on Nth term of an AP. Don't forget, we are still under series and sequence. So today we are working on Nth term of an AP. That's what we are actually working on today. Now, when we are talking about Nth term of an AP, before I proceed, let me quickly explain to you what we call Nth term of an AP. You see, I told you that AP and GP is a sequence. Now, we have some general rules that we use in determining the next term of our sequences. And that is what we call the Nth term of our sequence. But today we are working on sequence AP. And that is why we are working on the Nth term of an AP, meaning that we are working on the general rule we can use to find the next term of our AP. Now let us write, so that we don't waste much time. What is the Nth term of an AP? The Nth term of an AP is the general rule used in generating the terms of progression. Are we following? Hence, we have some terms used in AP. Now, we quickly want to consider the terms that we use in AP. Number 1 is what we call first term. The symbol that we use in representing our first term is A. Number 2 is common difference. The symbol that we use in representing our common difference is D. Are we following? And the last one that we're considering here is our Nth term of an AP, which we represent using Tn or Un or Ln. Anyone in these symbols is what we use in representing our Nth term. Alright, so this From here now we deduce our formula. What is now our formula? Our general rule is Tn is equals to A plus, open your bracket, n minus 1 bracket it, or close the bracket and put a D. This is our general rule that we use in solving our nth term of an AP. Now let's quickly move to the examples. Are we following? If you are following, say I am following. I'm not hearing you. Can you loud it and say I am following? I know some people are pressing for like that. So don't press phone at this time. Watch your video and what? And follow. Thank you. Alright. From here now, let's continue. Find the 8th and 10th term of the following. Find the 8th and 10th term of the following sequences or following APs. Let us do it like that. Number 1, 2, 5, 8, blah blah blah. Number 2, 3, 7, 11, 15, blah blah blah. Alright? Now, can we quickly do this solution together? Number 1, don't forget that we want to look for two things here. We are looking for 8th term and we are looking for 10th term. You will see I'm going to solve number 1. After I'm done with my number 1, we are going to solve number 2. Now, let us see number 1 and let's solve it together. Sequence of my AP is 2, 5, 8, and that is how it continues. Now, I want to find the 8th term of this AP. Don't forget I'm looking for 8th term, that is my n. My n is equals to 8. What am I looking for? I'm looking for T8, which is unknown. What am I given? My first term is the first number in my sequence. What is my first number in this sequence? And that is 2. So my A is equals to 2. How will I get my D? My D, I've explained that earlier in our video, that you have to minus your first term from your second term. Let us do that. My D is going to give me T2 minus T1. And this implies that my D is going to give me 5 minus 2, giving me 3. Now, with all this information, I can now find my 8th term. Now, let us find our 8th term. According to our Tn, the formula is A plus open bracket n minus 1 close the bracket D. This implies that my T8 is going to give me A plus 8 minus 1 open close the bracket D. Therefore, my T8 is going to give me A plus 7D. From here now, with this information, slot in all your values. What am I going to have? My T8 is going to give me, what is my A? My A is 2 plus 7 multiplied by, what is my D? My D is 3. From here, even without applying my bracket, using the law of BODMAS to solve your question, BODMAS, you will look at this equation and see that your times multiplication table comes before addition. You can see it. That is what you are going to apply. This comes before this, so you are solving this first before your plus. Now, this implies that my T8 is going to give me 2 plus 7 times 3 will give me 21. Therefore, my T8 is going to give me 23. This is the 8th term of my sequence. From here now, don't forget the next thing is to also find our 10th term. Now let us do that. Roman figure 2. I'm finding my 10th term now. This implies that my T10 will give me A plus 9D. Just minus 1 from your difference, you are going to get your answer. This implies that what will be my A? My A is going to give me 2 plus 9 multiplied by what is my D? My D is 3. This implies that my T10 is going to give me 2 multiplied by 27. Therefore, what am I going to get? My T10 is going to give me 27 plus 2, 27 plus 2, and that is going to give me 29. This implies that my T8 is equals to 23 and my T10 is equals to 29. This is what you are asked to do. If you watch this video and you find it interesting, like it, click on our video, and please share and subscribe. God bless you. Thank you. Welcome back our fans and our followers out there on Facebook, on TikTok, on YouTube channel. We welcome you all back to our program. Alright, don't forget, at our last meeting, we were talking about the nth term of an AP. That one is just the ordinary one. We have easy, intermediate, and difficult. Today we are working on the difficult aspect of our nth term of an AP. The one that we did last time, or let me say in our last meeting, it was just finding the nth term of an AP using the general rule. But we have some nth term of an AP that always, or let me say, that leads to simultaneous equation. And that is what we'll be working on today. You'll be wondering, how is nth term again forming a simultaneous equation? Yes, they all enter themselves. That is why we do talk about mathematics being differentiable and continuous. That is, differentiable and continuity is what mathematics entails. So today, let's see how we are going to be using simultaneous equation to pieces the life of nth term of an AP. Let's consider this question. Don't forget you are working on what? Nth term of an AP that leads to simultaneous equation. That leads to simultaneous equation. So let's see some examples under that. Examples. We have some few examples here that we have some examples here that we can work on actually. Let us see. The 14th term of an AP is 96. Let's see this example. The 14th term of an AP is 96. Stop. Comma. Why the 25th term is 173? Why the 25th term? The 25th term is 173. Find the column. Roman figure 1. 19th term. Are we following? Roman figure 2. Sum of 13th and 56th term. 56 terms. Roman figure 3. The products of 6th and 13th terms. Can we quickly tear this question into pieces? Let us check it out. Solution. According to our question, the 14th term of an AP is 96. This implies that our T14 is equal to 96. What else are we doing? Why the 25th term is 173? T25 is equal to 173. Now, let's interpret this statement. What is T14? Recall that T14 is equal to A plus 13D. And T25 is equal to A plus 24D. Now, with this remembrance, let us now jump into our question. What are we having now? Whenever you see T14, replace it with A plus 13D. This implies that A plus 13D is equal to 96. We can call this our equation 1. A plus 24D is equal to 173. We can call this our equation 2. From here now, let us solve. You will see that it is very obvious that our equation 1 is smaller to equation 2. This implies that you have to subtract equation 1 from equation 2. And take note of this in simultaneous equation. Before you can actually simplify, one of the variables must have a common value. If you look at our question, A is looking alike. We can actually now simplify our simultaneous equation by eradicating our E. Now let us do that quickly. How do we do that? You subtract equation 1 from equation 2. If you do that, what are we going to have? A plus 24D will be equals to 173 and our A plus 13D will be equals to 96. Don't forget that we are subtracting equation 1 from equation 2. What are you going to have? A minus A is gone. So you are left with 24 minus 13, which is going to give us 11D is equal to 96. When taking the read from 173, we are going to get 77. This implies that our 11D is going to give us 77. We are not looking for 11D, we are looking for D. So what are you going to do? Divide both sides by 11. Divide both sides by 11. Let us do that. 11D divided by 11 will be equal to 77 divided by 11. 11 cancel 11. What is our D? Our D is going to give us 7. Now, after getting my D, then I can solve for my A using any of my equations. I want to use my equation 1. In equation 1, solve for A. If I'm solving for A in equation 1, what am I going to have? I'm going to have what? A plus 13D is equal to 96. I've gotten my D, so I can replace my D. My A plus 13, open bracket, put my 7 is equal to 96. A plus 13 times 7 will give me 91. Will be equals to 96. Collect the like times. My A is going to give me 96 minus 91. What am I going to get? My A is going to give me 5. This implies that A is equal to 5 and my D is equal to 7. Now take note. I am not looking for A and D. I am looking for 19th term, sum of 13 and 15 and product of 6 and 13. From here now, I will now start my working full. So figure 1 now. My T19 is going to give me A plus 18D. Wherever you see your A and D, substitute for your value. 5 plus 18 multiplied by 7. What am I going to add? This is going to give me 5 plus 18 times 7 will give me, this is 6, carry 5. This is 126. Add it to 5, I'm going to get 131. This is my 19th term. Having gotten my 19th term, I will go for my Roman figure 2. I'm looking for what? Sum of 13 and 56 terms. This implies that I'm looking for T13 plus T56. Before I can actually get this, I have to firstly find my T13 and T56. Now let us do that. T13 is going to give me A plus 12D. And this is going to give me, what's my A? 5 plus 12 multiplied by 7. Which is going to give me 5 plus. This is going to give me 5 plus 84. And that will give me 89. What will be my T56? That is A plus 55D. What am I going to get? This is going to give me 5 plus 55 multiplied by 7. I'm going to get 5 plus 55 multiplied by 7 will give me what? This is 35. 35, 38. This is going to give me 385. And this is going to give me 390. Let's sum it together. T13 plus T56 is going to give me 89 plus 390. What am I going to get? 390 plus 89. I'm going to get 0, 7, carry 1. This is going to give me 470. And this is going to be my final answer, which is going to give me 470. That's the sum of 13 plus 56 times. So, that is, this is going to give me 9, not 70, it is going to give us 479. This is my final answer for my T13 plus T56. Now, for the last one, I will leave the last answer for you, or let me say the last question for you, as an exercise to practice on your own. I believe that somebody has gained another thing again today. That is what our program is all about. It's all about gifting to every weaker student in mathematics the way and the route for easy access and easy way of learning. Alright? So don't forget to click like this video, share it to your friends that also need this video, and please subscribe to our YouTube channel. God bless you. See you next week.